This video is going to go over some different compositions of trig functions and applications of inverse trig functions. There's going to be a lot of just like analyzing where angles need to be and a lot of using these domain restrictions right here for our three main trig functions. So because sine and sine inverse are inverses of each other, as long as we are on the domain of inverse sine, this is true. And as long as we, again, are on the range or the restricted domain of sine, then this is true. So if I need to find the inverse sine of the sine of pi over 3, since pi over 3 is in this domain here, and I like to draw, I remind myself on the unit circle that I'm right here. Since pi over 3 is in quadrant 1, that's really pi over 3 is more like here, then I'm good to go. These basically just cancel each other out, and I get pi over 3. But look at how b is different. I'm at 2 pi over 3. Well, let's go ahead and just figure out in quadrants 1 and 2, or from negative pi over 2 to pi over 2, where does 2 pi over 3 map to? And that's pi over 3. So I could say that this is the sine inverse of the sine of pi over 3, because that would give me the exact same number. And so these would cancel, and I would also get pi over 3. All right, let's look at inverse cosine of 2 pi over 3. So inverse cosine of 2 pi over 3. 2 pi over 3 is over here. Cosine, we go from 0 to pi, so we're good. This is 2 pi over 3 as my answer on C. However, here on D, I'm down at negative pi over 3, but inverse cosine, I'm only looking from 0 to pi. Well, cosine's positive down here, so this maps back up to pi over 3. So I'm really looking at the inverse cosine of a cosine of pi over 3. Again, this number would be the same as cosine of negative pi over 3. These cancel, and I get pi over 3. All right, let's look at another set of examples. Inverse sine of cosine of 13 pi over 6. Now for sine, inverse sine, I need to be here. Okay, that's the piece of this that's going to restrict my domain. So then cosine of 13 pi over 6, I need it to be in this domain. Well, 13 pi over 6 is 12 pi over 6, so 2 pi, just a little bit more, so we're right here. So what's the cosine of pi over 6? The cosine of pi over 6 is root 3 over 2. Well, now I want to find, which would be the same as the cosine of 13 pi over 6, right? I'm just restricting so that I'm in this correct domain. All right, well then the inverse sine of root 3 over 2, sine of root 3 over 2 is not going to be pi over 6. Sine of root 3 over 2 is going to be at pi over 3. So that's going to be my answer here. All right, let's look down here. I want to find the exact value for the sine of inverse cosine of 4 over over 5. Well, I'm going to rewrite inverse cosine. Like, where is the cosine of theta equal to 4 over 5? Well, since it's positive, and I'm going to assume that I'm in my domain here, of inverse cosine, 4 over 5 must be in quadrant 1. If you use this method here, it's actually pretty simple to then see that this is 3. And so the sine of that same theta angle is 3 over 5. However, another way that we can use this here is in the rectangular or Pythagorean identity. So we get sine squared theta plus cosine theta is 4 over 5, and I'm going to square that. So I get sine squared theta equals 1 minus 16 over 25. If I change that to 25 over 25, I get 9/25. And so I'm looking at sine of theta, square rooting both sides, being plus or minus 3 over 5. Since I know I'm in this quadrant, then I know I must be the positive component. All right, one more example. Let's try to figure out what the cosine of the inverse sine of x over 3 is. And notice I've restricted the domain here so that inverse sine is between -1 and 1. So again, the big question is, find the sine of theta such that you get x over 3. Let's just draw that here in quadrant 1, x over 3. But since x can be anything here, it is possible as well to have that piece. Let's go ahead and plug this into our Pythagorean identity. So that means I have sine squared plus cosine squared equals 1. It means I have cosine squared equals 1 minus x squared over 9. If I make this 9 over 9, then I get 9 minus x squared over 9. If I take the square root of both sides, then I get plus or minus the square root of 9 minus x squared over 3. Now, inverse sine, we're only looking here. Cosine, remember, has a different domain restriction on it. So the only place that these overlap is right here. And so that's the only place I can really talk about for solutions. Therefore, this must be the positive answer. You could also use Pythagorean theorem to find this side piece here. So you could say maybe that this is like a. So x squared plus a squared equals 3. A is then plus or minus the square root. Oh, not 3, 9. Of 9 minus x squared. And since I'm in that piece, it must be the positive. And then finding the cosine adjacent over hypotenuse, we end up getting the same answer here.